Hey, this is Matt from Dynamic, and today I am going to show you what you can do with Dynamic version 1. We just recently launched our stable v1 of our SDK, and it comes with a whole bunch of stuff. In fact, you can read more about it in the links below this video in the description. But for now, I'm going to teach you how to use it all at once. In a few minutes, you're going to have a web2 user log in a way which is native to how they perceive the world. You're going to have them mint multiple NFTs at once and authenticate for the transaction using a passkey. At no point should they be concerned about anything Web3 based, except having 2 NFTs, which is a good news. To do that, we're going to use a bunch of stuff, and I'm also going to customize the UI a lot along the way to show you some of these new features as well. So let's get going. What I have is a vanilla Create React app, customized a little bit for this tutorial. Now, there are a few configurations here in the dashboard that we're going to set up first. Okay, if we go here, we're going to generate an embedded wallet for our users. They will sign up with just email or social if we see fit, and receive an embedded email wallet immediately. We'll turn on email sign up here. In the embedded wallet section, we'll also turn this on. Recovery is a separate feature. I won't go through it too much today, but we will toggle it on. If a user loses access to their account, they can regain access by generating a new passkey and using that. We will change our claim behavior to on first transaction. This means that when a user gets a wallet generated, we can obviously put stuff in it. They can't sign for things. So if they want to sign for a transaction, then they must have some form of interaction with a private key, right? Almost, because in this case, we can actually sign using a passkey. So we will have the user add one to 1Pass or whatever else it is, or natively on their device. And we will associate it with this embedded wallet so that they can sign for transactions. Super. We will also make every new embedded wallet a smart contract wallet. In this case, we've toggled on zero dev. I've gotten my project ID. If you're not sure how to do this, links in the description below, as always. Those are the 2 main things which we want to do for now. We can go through many more. What we will want to do is make sure the chains that we're using are turned on. In this case, I'm going to use, I think, Sipulia. Okay. Wonderful. We have just 1 MetaMask user at this stage. In fact, to keep it clean, let's just do this. Super. Clean slate we have. All right, over to our React app. And here we have a few things going on. We have our environment ID directly from here, as you should, right here. We have something else, which we'll come to in a moment, some CSS overrides. This helps you override class names, which are declared by Dynamic, and change exactly what you want to put in them. You can do a ton of stuff. You'll see that I'm actually getting rid of content and replacing it with something else using some tricks, which you could call feature, you could call something else. In this case, it works for me. I just want to show you the length of customization you can go to. So those are the CSS overrides. Check the CSS customization link in the description. If you want to learn more about that, I'll show you what it's doing. Then we have something called overrides. This is a really cool feature which comes as part of V1, and I'll tell you why. You can programmatically say what login options you want to show. So for example, here in the configurations, you have down here what you want to show. So we say optimize for Web3 users. Wallet card will be the first option on sign up before email and social. Split email and social into separate sections if we have social. So wallets is first here. However, what we're going to do is say we just want email. So this is the use of the programmatic views feature. We say, and this has a certain type, that we want the login type. And in our login, we have sections, and the only section here is email. We pass that in as view overrides. We will only have email. So it's excellent if you want to, in your code, detect where is the user coming from, is it landing page A or B, and change the login method that you want to show to them according to who they are, where they're coming from. Really helpful. Now we also have our wallet connectors, and we always need to do this. It's in the documentation, in the quick start, it'll help you generate the code you need. But we're going to be generating Ethereum-based embedded wallets. So we need our Ethereum wallet connectors. And we also need zero-dev smart wallet connectors since we're doing account abstraction on top. Now, lastly, we have the locale, and this is a way of customizing any copy that the SDK shows you. So you can see up here, for example, we have sign up in the connect. So by default, it's connect your wallet. Here we want to adjust that. We want to do a web2 experience. In our info capture step, that's a separate feature which we won't go into too much today, just know that it's there. I edited the copy to make it a bit more friendly. Okay, so that's already 3 things which we're doing that you can learn about below. We're overriding the CSS. We are overriding how the sign up and login options are showing. And we are also customizing the copy as well, overriding that too. Now, in this instance, I'm using WAGMI, so I've added our WAGMI connector. No surprises there. Again, the quick start helps you get up and running with the code you need for this. And inside we have our dynamic widget, which, like I said before, we're going to use. There's a mysterious component down here, which we'll go into in a moment. But I want to show you that by default, this is what you get. Sign up right here. Awesome. Let's carry on with the experience and see what's happening. We're going to enter the email. XYZ. In fact, I'm going to put +1 here, just so we don't interfere with any existing passkeys. I'm now going to go away and get my code. So bear with me, back in a moment. I have my email OTP code. Here's our info capture step. It's optional, which is really helpful, but you know what? I'm feeling nice today. Let's tell them who I am. We continue. We now have an embedded wallet, just like that. User didn't even know what's happening. They didn't need to. This user has a wallet, which they can use to interact with the Web3 world. Now, what we want to do is get this user their first 2 NFTs. So imagine you're on a landing page. You have a collection of 2, which is your introduction to your dApp. Say, hey, you arrived, welcome. As a thank you, I'm going to give you your first NFT collection. Click mint to get started. And this is really where the magic happens. Behind the scenes, we're going to use this embedded wallet and do batch transactions on AA without gas. Super cool, eh? So when we click mint, remembering that we don't have a passkey yet, we can't sign for anything, and we should. So what we're going to do here is firstly, get an email code. And this is an extra step which helps re-verify the email. It's very important because since what we're about to do is give the user complete control to sign. Let me be back in a moment with that code. Okay, here's my code. We have re-verified. We'll now be prompted to create a passkey. Again, this is popular in the web2 world for good reason. So no surprises here. I'm going to create a new item in 1Password. That's done. It's saved. We're loading. What we're actually doing behind the scenes is minting. And you can see I'm now prompted to sign in with a passkey, which I'll do here on the right. So I'm signing for this transaction. Remember, I have 0 balance in my account at this point. Now this can take a moment because we're actually going through with the transaction, waiting for it to be processed. And depending on how things are going, it can take a few minutes. Boom. This user officially has not just 1, but 2 NFTs. Now we can look into those, but you have to take my word for it. This is honestly coded. This user has 2 NFTs, which is absolutely incredible. If we look in the inspect tab, I can give you the, there we go, transaction key, or excuse me, the transaction hash, and we can look that up. So what's happened here? Well, really, all we've had to do is define the dashboard configuration and then in the code process our transactions. Now I'm going to show you deep under the hood into how I've done that. At this point, if you're not interested in the technical implementation, feel free to drop off, just review the links in the description. Know that you can build this experience and more for your users with V1. If you're interested in seeing how it works under the hood, let's go. So what we have in here is our transaction. And there's a bunch of stuff which I'm doing here, so I'll just highlight what we need to be aware of. We're doing a few things, a few interesting things, like in our Ethereum AA package, we're checking for a zero-dev connector. This means we can programmatically determine, is the user's wallet that we're dealing with an account abstraction wallet? So this is just a safeguard for us. If it's not, we can return. We're also importing from the SDK React Core library our use passkey recovery method, or rather hook. And you can see that we destructure it into init passkey recovery process. This is actually the hook that's used to initialize, obviously, creating the passkey. So it's used for account recovery too, but it can be used on the first step to prompt in a headless manner the generation of the passkey flow. So we're using that down below, as we say when we hit mint. If you don't already have an authenticator, which I can show you down here, we check on the user object, which comes from use dynamic context. We check the verified credentials object, and we want to find the turnkey wallet in here. Now, I'm obviously making assumptions that there is one. You don't have to. I know my own demo. And we check in the wallet properties on this Boolean, is authenticator attached? If it's not, we just init the process. Then afterwards, we're checking on the primary wallet to check we have our connector. Again, just a safeguard. we start the process. What we want to do first is make sure that we're dealing with an AA connector. And if we are, there's an extra special method to get the provider. Here, it's called get account abstraction provider, because that provider is a bit different than the others. And what we do in this case then is on our provider, we have certain operations. In this case, we're using zerodev, and we get access to the ECDSA provider. Glad I said that right, which has the send user operation method on it. So we're passing this in. We have our target data, and this is being encoded. So we have the ABI of our contract, our function, which is mint, and the address, and we need to cast it as what the provider, or rather the method, expects. So we wait for this user operation after sending it, noting that we're sending not just one, but two of these. We're essentially minting the same one twice, but in one batch transaction. That is, in this instance, in the first, a user operation. So once that user operation transforms itself through as a transaction, we wait for it, and we get our hash. That's it. Very straightforward. So down here, if there's anything you wanted to see, it's that we have our mint button. After you've minted, we have a mint again button. Under the hood, that's everything we've done here. Back in the app, once again, nothing different. We're just employing our transaction component, which is defined earlier. And that's it, folks.